Now, another part of a script was the track, and we really haven't talked a lot about track so far, so let's talk a little bit more about it. So here are 4 tracks for the restaurant script. That really refers to going to restaurant of 4 kinds. Here's the coffee house, fast food, casual dining, formal dining. You could add more if you wanted to. Now, in restaurants of all kinds, some events are common. You have to go to a restaurant, you have to order some food, you eat that food, you pay the bill, and then you leave. That is common to all of them, which is why all of them are part of the restaurant script. On the other hand, what happens in a coffee house is quite different from what happens in formal dining, which is quite different from what happens in a fast food restaurant. So you may have specific tracks that correspond to coffee houses and fast foods and so on. In effect, we are building a semantic hierarchy of script. Here is a script for going to a restaurant, here is a script for going to a coffee house, going to fast food, and these can be tracks in the overall script. Of course, we can build a semantic hierarchy of something higher than this. We could think about going to for social events, and then going to a restaurant becomes part of going to a social event of various kind. Okay, now that we know something about the knowledge representation called script, the next question becomes, how may an AI agent actually use the scripts? So imagine an AI agent that is hungry and has some money and decides to do something about it. So it may go into its long-term memory and find out the script that will be most useful for the current situation. This really becomes a classification problem. In long-term memory, a large number of scripts, and the agent is trying to classify the current situation into one of those scripts. Let us suppose the agent picks a restaurant script and decides to execute it. As it enters the restaurant, the scene it observes in the restaurant matches the conditions of a fast food script, so it decides to invoke the fast food script. This way, the robot may walk down the semantic hierarchy, first invoking the restaurant script, then invoking the fast food script, and so on. Now, a robot could have taken a different stance. A robot could have decided to do planning. Given some initial conditions and goal conditions, a robot may have used the operators available to it to generate a plan at runtime. What the script is doing it is giving it a plan in a compiled form. The robot doesn't have to generate this plan at runtime. It is already available in memory in a pre-stored form. This is very useful because one of the central conundrums that we have been talking about is, how is it possible that AI agents can address computationally complex problems with limited resources in near real time? In a complex dynamic world, planning can take a lot of time. But if I already have these stored plans, then invoking the script and executing it is much faster.